Hey everyone, welcome back to the channel. So today we shall be looking at functions. So a function is a named reusable block of code that performs a specific task or a given calculation. You can think of a function like a reusable, whereby you have it defined once and you constantly keep using it for the different preparations of whatever meals that you might have. So functions are the fundamental building blocks of Python programs. They help us group related statements together. You'll find that in most cases, your functions allow particular inputs that we call parameters or arguments and have an optional return that gives us a response back after it has performed whatever computation that it has to do. In Python, everything is an object and functions are objects too. These can be assigned to variables, passed as arguments, and can be returned from other functions. So Python has three categories of functions. We have the built-in functions, examples like the print, the len, the range, the input. Then we have the user-defined functions. These are the functions you create yourself, having your actual required computation that is expected, that is required from it. Then lastly, we have the lambda functions, which are basically the anonymous functions. So you might ask yourself, why then do we need functions? Functions improve our code reusability. Functions make code easier to read and maintain. They enable us to break complex problems into smaller, manageable parts. And right there we have some examples of functions being used. One is basically adding two numbers that you have there, a and b, that is returning the sum of these two, a plus b. So you call your function with the arguments that you want to add, and this should correspond to the number of the parameters that we had defined in our function. So when you print out the result of this, you'll find that you have your output being 8. So it has actually been able to perform the computation of the 5 and the 3, giving us the sum as 8. So this is literally the function. So we are going to be looking at functions from the basics all the way to the complex advancements when it comes to writing of functions. So we shall kick straight into action by looking at a simple script, and we shall start with the syntax of writing a function. So in Python, we use the definition keyword to create a function. After writing the key definition, what comes in is the function name. So for example, if I want to add two numbers, just like we had in the previous, I would simply say definition, then what comes next is the function name, which is going to be add. Then I open my parentheses. And if this function is taking in any parameters, I put my parameters here. Then after, I will come and specify the body of my function. So this is our syntax of writing a function. Remember, the syntax is basically the language, the way how things have to be done. Yeah. So this is the syntax of defining the function. Definition, the function name, any parameters, then the body, the logic that this function is going to be computing. So I'll start with a very basic function, which is going to be a greeting function, a function going to perform a greeting to me. So I'll come and define my function. I'll call this greet. So the function name is greet. It won't have any parameters. And as of now, I'll simply print out. So I'll say, hey dev, good evening. Just like that. So I have defined my function. But right now, if I run this function, you find that we don't have any output. That means we need to call our function. So how do you call your function? So hashtag calling my function. I'll simply call the function name itself. So this line is calling my function, great. And when I execute this, I'll have my output, hey dev, good evening. So this is calling our function. One thing you should note is this function has no return. And it's only good to have your function written in this form if it just has a side effect to your code. But if this function is you're meant to consume the response, whatever it has computed, then you have to make sure you return that value so that you can consume that value it has returned for any other additional computations that you will have. Now let us look. If we try to print out this function, if I print out my great function, then you'll find that we have a none being returned for us. Why? Because this function doesn't return anything. So to have this function written in a better format, whereby it will help us to return a value, then you can define your function in this approach. I simply come and write the exact function, but instead of printing, I simply return the word, I simply return my greeting, which is going to be, hey dev, good evening. So in this form, when I'm calling my function, I can store the response of this function in a variable, which can be maybe my greeting. So I'll say my greeting is going to be the greet. So I'm calling my function and I'm assigning the return of greet to the variable greeting. Then finally, I can print out my greeting, just like that. And you can see that we shall have, hey dev, good evening. So in this format, we have been able to not only just print, because initially our function in the first cell, in the first block we created, it was just printing out. But with our next one, we are returning. Yeah? So when you return, you're able to consume the response, whichever way you might want. Yeah? So that is our function with a return statement. Now, our functions can be assigned to variables, just like we stated initially. So I could say my greeting is going to be my greet. Then let me just simply print out my greeting together as a function, because now I assigned greet to variable greeting. So if I call this, you notice we have the same exact output, just like this one. So variables are equally objects, and you can see that we have been able to demonstrate that. Yeah. Now, we stated that our functions can allow in arguments. We can create them with parameters and eventually pass arguments to them. So let us look at that. So I can create my function here. I can come and say definition, greet, and this time round, I'm saying that my greet expects a name. So after passing this name, I could say let it return something like a formatted string of hey, the name. Now I'll say how are you today? So this time round, this function is dynamic a bit. I can greet as many people as I wish. So I could say I want to greet Dave. So I'll say greet Dave. Then I'll print a greet of Matthew, and I can print a greet of Mike. So you notice that I'm reusing my function to perform different greetings for different people. So hey Dave, hey Mercy, and hey Mike. So this time round, our function is taking in a parameter, name. So when you're calling your function, you call your function with the argument corresponding to the number of parameters you've defined. So this is simply Dev, which is corresponding to this one parameter. So I'll say hey Dev, hey Mercy, and hey Mike, just as you see in our output there. So when you write your code in that form, that means your function is taking in some arguments. So these parameters are like the variables to your function. It can have one variable, it can have two variables, it can have so many variables, whichever format, whichever number of them that you may want, it will take them in. Now, when we are defining our functions, certain times it's good for us to specify the kind of data that our functions are going to be holding. For example, in my grid of the name, I could modify it. So I inform the user or whoever is going to be using the kind of information, the kind of data that the name is supposed to be. So I could say definition grid, then I open brackets. So I will say my name is meant to be a string. Yeah. And I could say my function is equally going to return a string. And after doing that, I can write my function body. So I'll come and say return a formatted string, which is going to be hello, the name. Maybe a good night this time round. So when you call this function greet, this function now expects that name to be a string. Yeah. So my name is going to be a string, and I've been able to define it correctly for the user that is going to be using this program. Unfortunately, my editor is still loading, but right here it would be able to inform us that now name is meant to be a string, and obviously the return statement is also a string. Okay, so now here I could pass Mike, and my function will run correctly. Hello Mike, good night. So you can specify the kind of data that your variables are going to be holding when you create your function. I hope that is clear. Okay, so whenever you define your functions, if at all the function is very complex, it's best that you define it. You inform the user, you inform people who are going to use this function, the purpose of the function, you describe any parameters that are going to be in there, you can describe the return value for it. So that makes your code easier to understand and maintain by other people and other developers that may interact with it. So inside my function, I can add in my docstring. Yeah. So I'll just copy this and I'll define it here. So within my docstring, I simply put it in between three quotations. Yeah. So I could say this returns, sorry about the spelling, returns the greeting for the name passed to the function. You can equally inform the user about the return type for this. Yeah. So since it returns a greeting, so in most cases this is a string. You can have a multi-line docstring, or you can have a single line docstring. So how would you now get to know about to access this docstring if at all you wanted to? So you can simply print out the function that you want, which is greet. So you want to access the docstring out of this. So you simply say the greet dot the doc. So if you run this, you'll find the description about this function. So this function returns the greeting for the name passed to rate, and that's going to be our docstring. So it's very important when you're writing functions that are so complex, so that other developers and other users can equally understand them easily whenever you've defined them. So let us look at position arguments within our function. So I'll clear this, I'll create another block, and in here we are going to look at the positional arguments. So positional arguments are arguments that are going to be passed to your function in the rightful order, the same way they have been created. So when passing arguments to the positional arguments, you have to ensure that they are in the same order within which they were defined with the parameters. An example could be my greet, my definition of the function greet, and I say I expect a name together with the message of greeting. Yeah. So I could say this function returns, maybe my message is going to be a formatted string of hey, the name, together with the message. Now when you look at this function, let us return our message. If you look at this function, the order within which these parameters are passed is very crucial. If you change the order, then the output is going to lose me. Most likely it's going to change the expected output because of changing the order within which these arguments are being passed to your function. So if I come and call greet and I pass my name Dev, then I pass my greeting to it. Then I come and pass my message to it. Hey Dev, wishing maybe you the best. Wishing you the best. So this is the rightful actual intended output I would expect. So hey Dave, wishing you the best. But if I reverted the order of these arguments, then I would get totally a different output from what I really expect. So if I run this, you can see, hey, wishing you the best, Dave. Yet my actual requirement is, hey, Dave. So positional arguments should be passed in the rightful order of how the parameters corresponding to these arguments are passed to the function have been written in the function. The order highly matters. So when it comes to the keyword arguments, when we come to the keyword arguments, order doesn't matter. I can call my function the same exact two ways I defined it there. So I'll print out this. But I have to define that now this is the name and This is the message. So if I call that and equally I come and print and I call greet in this form, but I define what the message is and what the name is. So these two are going to give me the same exact output like I would expect them to give me. The same exact output I intend to have. Right? So you can see that nothing has changed. So hey Dev, wishing you the best. Hey Dev, wishing you the best. Irrespective of the order. When you use keyword arguments, order of passing of these arguments is not necessary for as long as you specify that this is corresponding to this one. Now when writing your functions, you can decide on to make a function either allow only positional arguments or allow only keyword arguments. In this form, it is allowing both positional. These arguments can be passed either in positional argument format or keyword argument format. So let us look at allowing only positional arguments. So I can define my function the same exact way I've defined it, but after the last one, I put a slash, a forward slash. That means I'm constraining this function to only allow positional arguments. If somebody passes to it keyword arguments, then the function is going to crash. So let us look at it. If I come and call my function with this form, this is the valid way because we have said it's allowing positional only arguments. This works fine. Sorry, these are keyword arguments. So if I removed this works fine, as you can see. We have the expected output. But immediately we call our function with keyword arguments. This is going to crash our code. And you can look at the output. It's telling us greet got some positional only arguments passed as keyword arguments. So the failure is this, because we have put a constraint to our function. If I comment it out, the code runs perfectly well. If you write your program and you want it to only and only allow keyword arguments, then you don't do this, but rather you put an asterisk at the start, put a comma, then define your arguments, your parameters. Now, if you do that, this is going to fail the code because these are being passed as positional only arguments. And if you run this, you notice failure is there. So grid takes 0 positional arguments, but 2 were given. So if I call my function the rightful way, it expects me to call it with keyword arguments, then it's now valid. Yeah? The function runs exactly like we expect it to be. So nothing is working different, but rather exactly what I expect as to be the output. Okay, so in this kind of approach, writing your code, your functions in this form, you'll always have a fixed number of arguments to pass to the function. How about if you're not sure how many arguments you want to pass to the function? For example, you want to add numbers, but you're not sure how many numbers user is going to pass. So you can define your function as add numbers. So we can have variable number of arguments. Yeah? Variable number of position arguments. So those are the args. So star args, these are variable positional arguments. Arbitrary arguments. Variable positional arguments. So I can simply put here my args. Then since I want to perform adding numbers, I can simply return the sum of the args, right? And it's very important to note that args returns a tuple, yeah? So if you print out your args here, you will find that this is a tuple. Then finally, I can return the sum of my args. Now, this function allows variable number of position arguments. I can now call it in this form, add numbers, then I can pass 1, 2, 3, 4, any number of numbers I want to add. It's not 1, it's not 2. Yeah, you'll find the total computed for all those numbers. You can see my total is 30, but equally, your args is a tuple like I stated there. So this is a tuple, and that is the args. When it comes to the variable keyword arguments, we call them quads. So let us look at those. I'll create another block for it. So this is going to be the double asterisk of the quads, and these are variable keyword arguments. Variable keyword arguments. So for keyword arguments, we use 2 asterisks and the quads. Now quads returns a dictionary, not a tuple. It returns a dictionary. When you print out our quads, you'll find that it's going to be a dictionary. And since this is a dictionary and we know dictionary methods, so this is meant to return for us the sum of the quads dot the values, because our dictionary has keys and values. So our focus is on the values that have been passed to it. So I could say this is A, this is B, this is C, this is D, this is E, and F. So when you run this function, you'll find that equally the total is 30. It's not deviating away from that. But you notice our quads returns for us a dictionary. So whenever you're not sure of the number of variables that may be passed to a function, you can simply utilize the quad or the args when defining your function. Now we have another approach of passing variables to our functions, and this is concerned basically with how do you call this? This is concerned with yes. So next we shall look at unpacking our arguments. So hashtag unpacking arguments using the args and the quads. Basically, those single asterisk and double asterisks. So when we define our function, for example, like add numbers, yeah. If we call our function, let me just define it here. If I come and say definition add nums, open bracket, and I say this function takes in 3 parameters, A, B, and C. So just like there, I'll simply now come and say return A plus B plus C, just in that form. So basically it's returning the total of those numbers. So if I want to unpack my arguments using the asterisk, I could say the numbers we are going to add probably, let me say my numbers are maybe in a tuple. I want to add 1, 2, and 3. So what you do when calling your function, you simply call it add nums, open bracket. Then since these are in the form of positional arguments, I simply put my single asterisk and I'll say numbers. And this is going to give us, this is the output of 6. So if these numbers were in the form of key value pairs, A, B, and C, so our quags, keyword arguments, if my numbers are in this form of a dictionary, I say my A is 1, my B is 2, and my C is 3. When calling my numbers, I would call it with 2 asterisks. And equally it would give us the 6. So right there, we have been able to unpack our arguments using the asterisk and the 2 asterisks, basically corresponding to the arguments and the keyword arguments, the args and the quags. Now, all up to this way, we have been writing our functions. But what happens if you call your function? That is meant to receive a given number of arguments and you pass nothing to it. If I said print out my addnums and I don't pass anything, what happens? Your code crashes. It's expecting 3 required positional arguments, A, B, and C. So when defining these functions, we can write our functions with default values. So hashtag default values. You can write your function in default values, where I'll say probably my A is initially 0, B is initially 0, and C is initially 0. Yeah? And equally, you can specify that A is either an integer or a float, right? So I could say this can be an integer or a float. Similar thing I can do for B. This can be an integer or a float. And A can be an integer or a float. And since this is taking in integers and floats, either way, that means my final output can equally be an integer or a float. So we have modified our function. It's taking in some values, it's taking in some arguments, but we have defined default values for it. So in this way, I can call my function minus any parameters, and output is going to be 0. If I pass any number, maybe 4, that means I've passed 4 to A, and the rest are zeros, so I get 4. Yeah. If I pass this with 2 position arguments, 4 and 5, then I get 9, and so on. So you can see that this kind of approach now is safer for consumption. You would expect your code not to fail. Yeah. And you can call equally your function minus any arguments being passed to it, and it will equally compute correctly. So you can always take on these default values so that if at all a value is not passed to your function, then it can be assigned the default that you've assigned to the function during its creation. Okay, so I'll clear all my outputs and I'll create another block of code. Now we have so far looked at default values, we have looked at what args and quags are, we have looked at position arguments, we have looked at the return statement of a function. We have done already so much. Okay, so next we shall look at the actual arrangement of our variables, these different parameters that we have. So how would you arrange them when you're defining a function? So the order of definition of these variables is we start with the positional arguments, then we put in those that have default values, then we can add in any args, then we can have our keyword arguments come in next, then we can have the quads as well. So this is simple arrangement when it comes to the order, of these different arguments when passing them to the functions. Okay, so we shall now look at our scope of variables. So we have the global variables, we have the local, and the enclosing. So something global is what we define at the most top level of our applications. So I could have a global variable defined, something like my age is maybe 30, then I could have a function written that simply displays my age. And within this function, I can define again age as 10 and maybe my name as David HK. Then we return a tuple. I can say return the age and the name, which is going to basically be a tuple. So when we call this function, our age has a global scope. And these other variables defined in our function, variables defined in the function take on the local scope. Now, if I call my function of display age, if I display my age, you'll find that you have 10 and my David Hopke. So our age has not been tampered with. If I print out age, let me also print out this. If I print out these two, you notice that the age of 30 remained intact, whereas within the function, our age is simply a mirror of this, but it has no impact. Our 30 remained 30. And within this one, age is different. It's 10 and equally. So these are local variables. They are simply local to the function. The ones defined outside at the top level, they are global functions. So if at all your interest was to make a modification to the global variable, so hashtag modification to the global variable, what you would do, you simply, I would call this same code. I call this same code, but inside here, I have to reference the global. So reference the global age variable. So you simply say global age. So right here, we shall have the same exact output because our reference is to the global variable. And you can see we have 30 and 30. That means at this point, any modifications I make to the age equally will impact this age because we are giving reference to it. Finally, let us look at the enclosed variables. So I'll clear this output and we shall look at the enclosing variables. So within enclosing variables, you can define a function called counter that has a given value of count, and my count will be initially 0. So you can have an inner function to our counter function. This will be increment. So what increment does is it's going to give reference to the count variable. So I'll say this is a non-local and I'll say count. Right? So now count is an enclosing variable. So non-local count, and I'll simply come in here and say my count plus is going to be 1. Then return my count. And here we shall return the increment. So right there. Now since we have defined our function in that format, so we shall call our function where I'll simply say my counter is equals to my counter. Then we can print out these occurrences, right? Whenever you call my counter, it's going to call the inner function and increment this. Yeah? So this will give us our first one. So whenever you call it, it will increment. You can see. So we have 1, 2, 3. If you create another instance of the same thing, this would be a different counter. Right? If I say counter 2, I will call my counter again. Then I call my counter 2 and my counter 2. So this will be different count outputs. You can see 1, 2, 3, 4. This becomes 4. Then we call our 1 and our 2. Yeah? So these are different ways of calling out this function that we have created. So I'll clear all these out. Then I'll get to our lambda functions. I think before I get to lambda functions, we are going to look at our decorators. So decorators are ways of modifying our functions minus us actually changing the actual function that we have at hand. So decorators add functionality to our programs. For example, on our greet function we defined, I would come and say, I need to write a decorator for it. That is simply going to be checking for the length of the name that I would pass to it. And if I told this length is more than maybe say a given number of characters, then I don't greet that person. So I'll call my greet, so definition greet. I pass to this function maybe args, whatever I want to pass to it, or you can pass to it the name. Then you could say print or return. What are we going to be returning? We shall return maybe hey, the args at 1. So this would be formatted. Hey, the args at 1, maybe together with whatever message that is going to be passed to it. So this could be my args at 1, args at 0, args in 1. So we can write a decorator to help us check whether our name is greater than maybe a given number of characters. And if at all it is so, then we don't greet the person, but rather we give them a custom message. And if it's less than, then we perform the greeting. So we come and write our decorator here. Our decorator takes in a function, and within it we have an inner function that we can take in the args and the quags for the corresponding function that it's having. Then we can put here our logic to implement, which is the added functionality prior to calling the function. So my focus is going to be checking for whether my name is longer than a given number of characters. So I'll say if the args at position 0 and our focus is in the length of that name. If the length of this name is greater than 5, right? You want names shorter than 5, things like hope, right? If it's greater than 5, then what do? We shall simply return a message to them. We shall tell them, hey, your name is very long, right? I think I will center this to 20 and we shall populate it with asterisks. Other than that, we perform our greeting, right? So here we can have our inner function being called together with the args that it could have, and any quags if at all there are any, but now we don't have quags, so I could simply leave it with that. And I'll have this be captured in my body as my response. I'll call this my response is that. Then after, what do? We return our response. And finally, we return the wrapper. So we have written our logic that is going to be called whenever we call our function greet. So we shall pass greet to the decorator, perform that logic, and finally give us back a greeting. So to enable that to happen, we use the at decorator. We decorate this with our decorator we have defined. Then I can come and now perform my greeting. So I'll say print greet. I'll greet Dev. Then I'll print out greet of Daniel. So 1, 2, 3, 4, 5, 6. So Daniel is greater than 5. So when I run this, okay, I have a challenge here. So let us see tuple index out of range. Okay, we are having the name together with the message. So how are you? And this would be good evening. So this should now be able to run. So as you can see there, hey Dave, how are you? This works. But for the name greater than 5 characters, it fails. Hey, your name is very long. Yeah. So this has failed totally. So it can't execute, it can't run. And that is it for that part. So that's our decorator. Decorators enable us to add functionality to our functions minus actually modifying them. That's why you see that we have a function here that has added functionality that we are passing to our greeting. So finally, let us look at our lambda functions. Lambda functions. So lambda functions are imaginary functions. They are meant to only have a single expression within them. And we're going to be seeing how to write one. So I'll use this similar example of greeting to have my lambda function defined. So I'll say greet is going to be my lambda that takes in a name and returns whatever that we want to perform the greeting with. So it will be hey, the name, how have you been? So I can print out this greet and I'll pass Daniel. And you can see that we have same exact output just like before. So hey Daniel, how have you been? So these lambda functions have so many applications. For example, you can equally use them for filtering. Yeah, I have a list of numbers. A list of numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So you might want to simply filter out even numbers from this list. So you can come and say my even numbers is going to be equals to a list, and you perform your filter. So in the filter, you're going to have a lambda written there. So lambda, and we shall take in x and check whether that number, that instance. So x modulus 2, if x divided by 2, the response is 0. That means we keep it there. And what are we applying to this? It's the numbers. So when you print out your even numbers, you'll find that you have a perfect filter of only even numbers, right? And how have you been able to achieve that? With the help of a lambda function. So lambda functions are smaller functions. Whenever you think of writing functions, think about lambda functions. For as long as they don't have a lot of logic, just single expressions. But if you have more logic to write, then in there, don't think of a lambda function. Go with the definition of your function. So having talked about all those about functions, I think this gives you now very good insight into how to write your functions, how to use them. And as of now, I expect us to be able to use functions with vigor and apply functional programming to all your programs that you're going to be developing. So thank you so much for watching, and we meet again in the next tutorial I'll be sharing with us. Yes, thank you.